Good morning, fancy meat computers. How is everybody today? This bright November. Wow, it's November already. This bright November day. Choopa choopa choop. Seems like there's like a really low number of people watching at the moment. Uh-oh. Nope. Are we good? Are we okay? Are we okay? Testing, testing, testing. We just finished class. Most people are probably walking to their dorms. Why am I on Wi-Fi? I should be on my wired internet. Give me a second. I think maybe the cable got unplugged. Okay, that'll do. I was having a tough time untangling my earbuds. Yep. Yep. That checks out. Okay. Okay, well, we're getting more people as time wears on. You know, if you guys want to watch if you want to watch these from the lecture theater, if that's more convenient, I can give you guys the projector code. Anybody have their, anybody in the room? I can give you the projector code. I'm just going to give you the code. Boom. Excellent. By all means, I authorize this. All right. Well, time to get going. All right, let's do this. So, we were talking about testing and exceptions. We had finished talking about testing, and we were just getting into exceptions. So, we were talking about, like, things that don't make sense. Doesn't make sense to return false in the case of something failing to compute, right? Often, it's just not a good idea. What is this code for? There's a little black tablet thing on top of the podium, right? If you touch that touch screen, if it's not already activated, it'll ask you for a keypad input. If you put that code into the keypad input, it will unlock the AV system, and then you can like either use the podium computer or project from a laptop or however you want, whatever you want. Yeah, it's the nuclear launch code. But the only nukes that we're launching are radiation burn level memes. Anyway, so I'll stop beating around the bush. The way that many modern programming languages choose to deal with the problem of invalid inputs and errors occurring during program execution is the exception. Exceptions allow Python to deal with... Thank you, Austin. Exceptions allow Python to deal with situations where it tries to execute a statement that isn't well-defined or violates some condition. Python raises exceptions. Raise is the correct verb. This interrupts the normal flow of execution. What an execution does is it interrupts the whatever is processing at the time that the execution occurs, and it will look for the most recently defined exception handler, which will try to recover from the exception which occurred. If there are no exception handlers, or the exception handlers are not for the right type of exception that occurred, you have what's called an unhandled exception, which causes the program to crash. So, here's an example. Actually, I think I'm just going to do Python. Here we go. Python 3, def ask AMA There we go. Input, let's say x is equal to cast as integer, input, enter an integer. Return x. AMA. Enter an integer. 8. So it gets 8. Enter an integer. No. Value error. Invalid literal for int with base 10. No. So there you go. Basically, the input function is designed to throw a, or raise a value error when it receives something that... No, sorry, this is the int conversion. So int conversion is, when it operates on strings, is meant to it's meant to raise an exception when it receives something that can't be converted to an integer. Which is, you know, the type of thing that you'd get if you were being sassy with the interface. We can handle this exception. So you might be used to try catches in other languages. In the case of Python, we have try except blocks. So let's define a slightly different one. Def AMA2. Try x is equal to int input enter an integer. There we go. Except in the case of a value error, print. Oh no. Oh shoot. I hit the wrong button and now. Ugh. No. I really want to redefine that. Give me a second, guys. Try. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Are you a fool? Are you a stupid fool? That's a Monty Python reference. So in this case, when we enter an integer, we just get that, you know, the thing behaves normally. But if we put something in that's not supposed to be there, like potato, then it complains at us. So try except blocks are very, like, so this is how they work, right? They're a bit like if statements, except the second case will only execute if an error occurs during the execution of the first block, right? So anything inside the try block is something you should put inside the try block, something that might result in an exception. If an exception occurs while this is executing, we immediately quit whatever we're doing here, and we execute whatever is contained in the except block for the error that actually occurred. So in this case, we just have this slightly abusive print statement. If no error occurs during the execution of the try portion, the except portion is not executed, right? So, yeah. It's not too bad, actually. Relatively speaking, this is like one of the easier things in this course. Good. So, put code that might cause an exception inside a try block. Use one or more except error name blocks to specify what to do if the code causes one of these exceptions. You can raise exceptions in your code if it enters a situation your code isn't intended to handle. So raise is also a keyword. You yourself can produce errors. So, for example, if you think back to the factorial example, the factorial isn't defined on negative numbers, right? So, one thing that you could do is you could raise a domain error. Domain errors don't exist. You could raise a value error in order to, you know, like, actually, you know what? Let's just go back to one of our code examples, and I'll show you how it works. Yeah, factorial. So, if n is less than 0, raise value error, right? So then, if we want to, if we request the factorial of -5, for example, Python 3 topic 3.py, you'll notice that we get a value error, right? We can create our own exceptions. There are many different types of exceptions, not just value errors. Value errors are used when a function or operator is applied to an object of the right type, but it's otherwise not appropriate. So, you know, factorial isn't defined for negative numbers. If you get a negative number, that's a value error. When you get something given to you that's just completely the wrong type, right? Like, for example, if you tried to put a string into the factorial, like, you know, if we tried to say something like, you know, the bee's knees, you'll notice that we have a type error instead of a value error. Less than is not supported between instances of string and integer. So what that error is telling you is that the less than operation does not compute, like there's no definition for it to compare strings and integers to each other. So that's a type error because the types are incompatible. We also have an index error when the index to a list string, etc., is out of bounds. So if you're trying to access outside of the bounds of the array that you have, that's an index error. I'm sure many of you have seen many of these already. Not implemented error when a function has not been implemented. This essentially functions as a placeholder that programmers will put in the code to say, hey, I'm not done this feature yet, don't use it. Recursion error, when the maximum recursion depth has been exceeded. It's relatively self-explanatory. Runtime error, some error that occurred that isn't classified elsewhere. For example, if your operating system runs out of memory in the middle of your program being executed, that would qualify as a runtime error. And of course, zero division. Zero division cannot occur in a computer, so anytime you divide anything by 0, that immediately causes your program to crash. And finally, we have the assert statement. Assert raises an assertion error if the expression evaluates to false. So you put a Boolean expression into it. If this guy comes out false, it raises an exception. It's excuse me. Syntactically, it's just syntactic sugar for this. If condition raise assertion error. Oh, Sorry. If not condition, raise assertion error. It's just this in one line. Right? Assertion errors, by the way, are the way that we like assertions are used quite a lot in the autograder. The way that Jupyter works in general, if you have a code block, right, or like a testing code block, basically the thing that gets you a grade is that code block executing without raising an exception. If any exception is raised whatsoever during the execution of that test block, you don't get the marks for that test block. So we use assertions to raise errors if, the outputs of your function don't match whatever condition we'd like to apply to them. Normally, we're looking for the output to be a particular value. Make sense? Cool. Any questions about any of that? Because if not, we're going to move right along to topic 8. Give me a thumbs up if you're cool with this stuff so far. Oh, and perhaps I should say, before we get, while we're in sort of slide transition mode, the TAs and I are performing analyses, have been performing analyses on recently submitted assignments to check for plagiarism, and it turns out that the warnings that I gave at the beginning of this class went largely unheeded. If things continue at their current rate, we will probably be convicting about a third of this class of plagiarism as well. There are quite a few people who are pulling answers off of internet sources. There are quite a few people who are cheating together. Although, at the moment, there's like one big cheating ring that has like 6 people in it, and like a couple of other cheating, like partners cheating sort of couples. And, I say that only a little bit facetiously because it turns out we actually get a surprising number of cases that are like, boyfriend, girlfriend, and they're cheating off each other because of the power dynamics of that particular type of relationship. Yeah. Yep, there are going to be letters. There are going to be lots of letters sent out, in the near future. On assignment 4, we had 22 instances of people committing plagiarism. So, yeah, like I don't know what it is about this Chegg site, but like people just, it doesn't matter how many times I tell people not to use it, they use it anyway. I guess they think I'm not checking. They think we're not checking, even though we say, listen, we are checking this specifically. Don't use it. They still use it. I don't get it, Like, I don't know. I have a theory that, like, the people who use Chegg just, like, completely can't program at all, so the only reason they're in the program in the first place is because they've cheated to get here. May or may not be unfair, but you can understand how I come to that conclusion. Do they get an email warning? No, they just get a conviction. No warnings. No warnings. You just get convicted. Most of the cheating comes from Chegg? I don't know if I'd say most. It really depends. Like, it varies by assignment. Sometimes it's more Chegg than partners. Sometimes it's more partners than Chegg. It depends where we are in the semester. It depends on how many convictions we've sent out so far. Um, you know, giving people convictions really tends to reduce the amount of partners cheating, but not so much the amount of Chegg cheating. For whatever reason, the people who cheat on Chegg tend to do so even after being caught. So, it is what it is. So, and it's not just Chegg, it's like also, other internet sources, but like Chegg is such a hub of plagiarism that like basically all internet cheating has like, we're almost to the point where we consider, you know, we kind of collect up all of the answers on the internet that we find and just call them all Chegg because so many of them are found on Chegg. But yeah, no warnings. You just get a conviction. How do you know if you got a letter? Because you would have gotten it by now, I think. But if you haven't gotten a letter, then don't worry about it. It'll come to you in your McMaster email. Your Mac ID email is the one that's used for that type of thing. So, yeah, just don't cheat, and we won't have to worry about it. I would really appreciate if people stopped cheating. Actually, it would save us a lot of work, But at any rate, so let's talk about classes. How many people have worked with objects and object-oriented? I'll do that as a survey. Let's see. How many people have used OO before? And I mean, like, actually having used classes and understand what you've, like, designed your own classes and used them and know what you're talking about. Right? What will happen if you get a conviction? First conviction is a 0 on whatever you cheated on. Second conviction is you get 0 in the course with transcript notation. Third conviction is you get suspended or expelled from this institution. So yeah, it's quite serious. Okay, so about 2/3 of people. So object-oriented languages are extremely popular. One might go so far as to say, if you're being paid to code for a living, there's like a 95% chance the language you're using to code is an object-oriented language of some form or another. Objects are a means of abstraction which allows you to bundle together procedures with data. Question. Is OOP in Python different from OOP in Java in a significant way? It's far less protected. And it's like, you know how I've been complaining about Python's dynamic duck typing this entire course? Well, like when we get into how classes are defined is really where Python falls flat on its face in the mud. Like, I wouldn't recommend Python for large projects because of the way its classes are implemented. That being said, all of the sort of bare bones functionality is there. It's just like written. It's just done horribly. So, like, if you already know how to program using, if you already know how to program using, using classes in other languages, like, things like inheritance will still apply, right? it's just done terribly in Python. So we're going to motivate this by example, right? So you can raise, so we just talked about exceptions. You can raise exceptions in your code if it enters a situation your code isn't intended to handle. So, for example, find first even, return first even number in a list L, raises value error if there is no even number in list L. There you go, reasonably simple. There's no abstract classes in Python, right? Not specifically designated abstract classes. You can use classes as abstract classes if you want to, but basically the thing that distinguishes an abstract class from a regular class in Python is that you never actually create an object from it. So, all right. So before we get into this example, I'll just talk very quickly. There's some really, really important nomenclature that we need to get out of the way first. All right? So what a class is a template, right? A class defines some set of member variables and some set of member functions. It's the same idea as defining a function but not calling it, right? You define a class, but the definition of the class itself does not create anything with those attributes. You instantiate classes the same way you would instantiate a variable to create objects. That's where the object in object-oriented programming comes from. So an object is an instantiated version of a class. So it's like instantiating a variable plus, making functions available to be executed on that data. We're gonna see how it works. Don't worry, we'll get there. It's important right from the outset to understand the distinction between classes and objects. An object is created from a class, right? The class exists independently of the object, but the object cannot exist without a class first. All right? Class is the template. Object is the thing that is created from the template. Okay? Good. So, is it also a good way to consider classes as blueprints and objects as the implemented blueprint designs? Yeah. Yes. That's another way. That's another good way of putting it. Yeah. Again, in some sense, you could say like a blueprint is a template for a building, right? But yeah, it's like the class is the design. The object is the thing that follows that design. Class equals Platonic form. Not quite. Because as we're going to see, classes have no concept of perfection. But I love the philosophy reference. Thank you. I would not consider the class to be the perfect form of the object, right? But anyway, we'll get into it. So with exceptions, we have assertion error, index error, not implemented error, recursion error, runtime error, type error, value error, zero division error, and others besides. But what if we have a situation where none of these pre-existing exception types is appropriate for the scenario we're in? Well, my friends, you can define your own custom classes to describe custom errors. But you can also... Okay, I get ahead of myself by one slide. One thing you can do, if you want to increase the sort of usefulness of your exceptions that you're raising in your program, you can actually tie... you can tie error messages to them, right? So, value error. This is an error. So you can make it so that your exceptions, when they occur, give a customized error message. But this is different. What we want is we want something that you can actually use inside of an except block, right? So, you know, you want to be able to catch that error as an error. You want to be able to say, accept my error, and then do stuff with that, right? We can create a new type of exceptions using classes. So, class myError inherits from an exception. Class myError inherits from exception. Pass. Pass is a statement that does nothing. It basically, if we were to just put this line here and then just have nothing afterwards, that would be a syntax error because it's expecting something indented, right? So pass is just a placeholder to say, I wish to define nothing here, right? So now we can raise my error. And you can see that my error is a type of error that can now be raised. You will see that it, for those of you who know a little bit about classes, my error has been defined as a subclass of main, which is also a class. The little 2 underscores on either side are something we're going to talk about, but that basically defines Python's prelude stuff. Cool. So essentially, what this is doing, it's saying, I wish to create a new class called myError. I wish that class to contain everything contained in the exception class. The exception class is defined by Python, right? It's defined in the Python prelude. And like that's like the class that makes exceptions work, right? Exceptions, exception handling, all that kind of stuff. It operates off of the exception class, right? So by basically coming up with a new class, which is essentially a renamed version of exception because we haven't actually added anything to it, we can create exceptions with their own class names. So far, so good. Hopefully. Give me a thumbs up if everybody's doing good. Incidentally, this material is material where if there are people who have been using Python for a while inside of in their high school or elementary school careers, your knowledge will very likely exceed mine on elements of Python's class system. So this is always where the sort of know-it-all programmers are like, well, that's not exactly true. So just keep in mind that this is I am attempting to present a sufficiently, high-level description of how object-oriented programming works that it can be applicable to languages other than Python. But at the same time, I'm always interested in hearing your, I'm always interested in learning more about Python as a language. Not because I like it, but because it's useful for my career. So, good. All right. So, let us speak then on the subject of a family tree consisting of a well-known fantasy novel series, a series of characters in a well-known fantasy novel series. I would just like to say that these books have too many characters in them. Just in general. Frig man. Your book should have probably no more than 10 characters. If more than 10 characters and you're overdoing it. That's what I say. But anyway. So let's imagine, just for the sake of interest, we wished to define some kind of data structure which would allow us to keep track of this type of information. Also, it's kind of interesting, I'd just like to point out here that, everybody in this diagram is, in chibi version, and it's, they're all depicted as being the same age, which is kind of funny, because, they're all 16 or something in all of these portraits, but, there's, the grandparents are depicted as the same age as the grandchildren. It's kind of weird and funny. I think that's amusing. Anyway. So. I see I've stoked some controversy in the chat. Excellent. So. How might we go about this? Well, one approach might be to define a series of dictionaries. We might define a dictionary containing name, children, and spouse as fields, and populate these fields based on the relationships between each of these various characters. You'll notice that in the case of children, we're actually aliasing existing entries rather than just providing the names here. This is fine, right? So, where did I get the avatars? I did not. This came to me. This is inherited from the people from Dr. Stabila who made these slides. But it's silly to ask me where this diagram came from, because it's linked right on the slide. Come on, man, use your eyes. So, when you have, a series of dictionaries or something of that nature, which are all being used in the same way, right? All of these dictionaries are defining the same keys with the values changing. You have developed what is known in the biz as a coding convention. So you have developed a convention so that when you're dealing with these dictionaries, they can be accessed in some kind of reliable way, right? All of these guys have a name field, they all have a children field, they all have a spouse field, right? So because of these, no matter which one of these you're accessing at any particular time, in theory, you should just be able to access name, children, whatever, and not have to think about it too hard. This is a coding convention, right? So the convention was that every person was represented by a dictionary with 3 entries in the dictionary, etc. So here's a question. What if, while coding along merrily, you accidentally type the wrong key. So children instead of children. If it's an assignment operation, it will just create a new instance inside of the dictionary. What if I forget a key in one person's dictionary? Functions that expect certain keys might be to be present might fail. So if if my function assumes that there's a spouse field and I forget to add one, that's going to cause an error. We also can't use type or is instance to distinguish between dictionaries that represent people and dictionaries for other purposes. So basically, we have a coding convention, but what we have not done is formalize that coding convention so that so that we can lean on the programming language itself to help with enforcement, right? And again, Python isn't a great language for enforcement, but it is what we're learning, so we'll have to bear with it. So by codifying this as a class, right, we don't have to rely so much on fallible humanity to program correctly, right? You don't have to, type everything out each time or rely on somebody copying and pasting adequately. So how might we go about defining this as a class? Right? Let's do a coding example. This is a Code with Prof live coding session. Please get your coding devices ready. Good. So, class, person, inherits from nothing. The first thing that we want to do is define a constructor. A constructor is a method of a class which will be executed by default when that class is created. In Python, the way that you define a constructor is def init with 2 underscores on either side. You then provide a list of arguments. Self, and that'll be it for now. Self dot name is equal to blank string. Self dot children is equal to empty list. Self dot spouse is equal to empty string. Good. So far, so good. So the way that we define, so this is our class definition, very short so far. The way that we use it, there we go. Let's say Nick is equal to person. All right. That so when you use the name of the class and you just call it like it's a function, that activates the class constructor, returns a reference to a newly created person object, stores it in the variable Nick. So next we want to populate the fields. So nick.name is equal to Nick Moore. Nick.children is equal to, and I'm just going to produce here, Felix and Cordelia. Nick dot, and I know this was like supposed to be references to other data structures, but I don't care right now. Nick dot spouse is equal to Allie. There we go. Print And let's just print this stuff, and we'll see what we get, eh? Yeah, get out of here. Get out of here, you! Nick.name print Nick.children print Nick.spouse. Spouse. There we go. So. There we go. So, you can see the string, so name, children, and spouse are printed out pretty much as you would expect, right? This, by the way, is known as dot syntax. The way that you access the things contained in a class is by stating the name of the object, right? Putting a period, and then the name of the thing inside the class that you want to access. Right? Interestingly, if you print just the object name itself, you get this main.person object at this address. This is not quite the same thing as the name being a reference to. Well, it is okay. So the name of the object is a reference to the object, but if you print it, it prints out as like that. It prints out, you know, the address of the reference to the object with this other stuff included. Make sense? So far, so good? Hopefully. So there we go. To define a new class, use syntax What we say that my class name extends what it's built on. I'm probably going to use C++ terminology here because I like it better. So in the exception instant, for exception, my error is the derived class, exception is the base class. Right? Good. So I'll just throw in a couple of points for you advanced programmers in the crowd who already know what you're talking about. So Python methods, the first argument of any method in Python is a self-referential, right? By default, it's called, or by convention, it's called self, but you could call it anything. In order for you to bind variables to the class itself, rather than making them local to the method in which they occur, you must address them self-dot, right? And if you wanted to add an argument here, I'll just demonstrate that quickly. Let's say you wanted to initialize it with the name. Do it in French. Nom nom nom. In that case, if you put this here, right there, bang, bang, boom, everything still works the same way. All right? So this gets bound, right? You write it here, but self, whenever you call a method, self is bound to like the object on which you're calling the method. So like if I had Nick dot is married, which is one that we're going to see, is married the self would be bound to Nick in that case. Good. Any questions? Like and subscribe. Are all variables public in Python objects? Nope, you can lock them out and make them private. You have to precede them with 2 underscore characters. That makes them private. So we'll see how that works. Did I save that? You can see that it's still working. So what's going on here is that and this is one of the reasons Python is terrible, nick.children is actually adding a new field, self.children, that is public and giving it this value. That's why that's still working. Because in Python, you can define member fields, you can define member variables from outside of the class definition. If you don't want to include self, would it simply be local to the function as opposed to the whole object? Yes. So if you leave out self, name would be bound to the method rather than to the class. Is it bad convention to include variables that don't include self in a class? No, it's not bad convention. It just it's kind of like the difference between public and private. It's kind of like the difference between global and local variables, right? It's like global to the class, but still local to it's global to all of the functions in the in the class, but local to the class itself. No, it's absolutely like, you know, if you're writing a complicated method, you might need some variables to do, you know, programming and stuff. So local variables inside of methods are absolutely fine. You know, just don't include self. Yeah, no, it's good. What is the difference between private and public? So the analogy is this. All right. Imagine a class was a fast food restaurant, right? There's a public-facing portion of the restaurant and a private-facing portion of the restaurant, right? The public side is like the dining room plus the counter where you get the food, right? The private side is the kitchen where the food is made. Stuff that's private is not accessible to the public, right? There's a great big sign that says employees only. That's like the quick analogy. It just makes the name super ugly. Python has no proper private variables. Correct! What does init do? It's the constructor. Init is run when an object of this class is created. Python can create new object fields from outside the object class. Yes. Yes, yes, yes. Do all methods need to include self as a parameter to access its own variables, or is it just init? All methods. You can add fields to objects anywhere, and Python passes in a value for self no matter what, but you can call it anything. Yeah, self is just convention. Yes, thank you. Yeah, it's always the first parameter. Like, for example, when we do def is married, it's going to look like self. It's going to look like this. Return self.spouse not equals empty. Right? Yeah, you can do like def banana, this is now self argument. Yeah, correct. Yeah, it seems that Village knows what he's talking about. He knows what he or she is talking about. Can you pass class as a variable in functions? Oh yes, you can. Well, you can pass. You can pass both objects and classes to functions as arguments. Absolutely. Yep. Any other questions? We are running out of time. Yeah, no, I'm very happy that you helped. I don't mean, like, please, let's make this a collaborative learning environment, just like the university wants us to, eh? Yeah. Yeah, if you know what you're talking about, please feel free to talk in the chat. Yeah. More communication is better, generally. Okay, well, I'm going to end the stream here. I'll see you guys on Friday.